Hello and welcome to section 2 of the Intro to Python. In the first section, we covered first, an intro to Python and the basic history of it. Second, we covered variables and basic data types, conversions, and application of conversions. And third, we went over functions and basic conditional statements. Now we will be going into the fourth and sixth sections of this course, namely lists, accession, comprehension, and functions. Now let's get right into it. Obviously, in the past course, I taught that there were 4 basic data types. However, when it comes to variables, you can actually have many other types of data types, 2 of them being tuples and lists. Now, a tuple is a set of 2 values that are enclosed by parentheses. Keep in mind it is important that they are enclosed by parentheses specifically, because that's what denotes a tuple. For example, 0, 1 enclosed in parentheses is a tuple. Next, another type of data type is a list, or a set of multiple values enclosed by brackets, and also separated by commas. Examples include, like I mentioned here, brackets 1, 2, 3, 4, 5, 6, 7, close brackets. What makes tuples and lists quite unique is that they're one of the only data types, or some of the only data types, to make sure that they can hold multiple values in one variable. Lists can also hold other lists, and can also hold many other types of the basic data types. Let's quickly go into an in-depth discussion about lists. Lists, like I mentioned before, are another type of variable in data. And they're important in basic Python because they hold multiple values in one variable. Later on in this course, you will learn other types of data, like arrays and series. And they are based on the basic definition of a list. However, in the basics of Python, it is imperative that you learn lists, because they're important for accessing and manipulating multiple values. You can also create rudimentary datasets, and you can also hold multiple values. Now for accession. Accession, or rather list accession, is a basic sort of indexing. Now, an index is a position of a certain item in the list. Say, for example, you have a list name of A, as example given in this function. The index of bacon, tomato, or ham would be 2, 3, and 4. Indexes start from 0 and end at 5. The first term of any indexed list is 0, while the last term is the count minus 1. As you can see, there are 6 items, but the last term is denoted with a 5. Now, how do you get indexing, and how do you ensure that you can pick out values using indexing? Now, here are some examples of how you can use indexes to ensure that you can actually get values. Say, for example, you have list and index of 0. That returns a value of 0, as seen in this rudimentary list of 0, 1, 2, 3, 4, 5. When you do list of 1, you get 1. List of 2, you get 2, and so on and so forth. You can use a colon to slice lists, which means taking certain parts of lists. The colon usually has at the beginning the first index that you want to take, and at the end, the last index of the data set you want to take. The last index is usually not included, however, as seen in this example of list 2, 4, which takes 2 and 3. Sometimes when you don't specify a value, it gives you all the indexes after the specified number. Here are some other basic list functions that will be explained more in depth in the implementation section of this lecture. First, listName.count of a certain item in the list will give you the amount of times the item shows up. ListName.append adds the item at the end of the list. ListName.remove removes the item, and listName.pop is specific that you have to use the index, not the name of the item, and removes the item at the specific index. As always, for more specific details on how to manipulate lists, you can always check online because they will definitely have specific modules and very niche list functions that can ensure that you can do the task you require. However, for machine learning and for the basics of machine learning, this is all you need to know. Fifth and sixth lectures, or rather parts of this lecture, are the most important for you to grasp. That's list comprehension and lambda expressions. Let's get right into list comprehension. List comprehension is perhaps one of the most efficient ways to create lists, because all you need to do is create lists in only one line. You can specify loops, the equations, and conditions that you need to be condensed into one line of code. This makes your code a lot more organized and compact. You don't have to define a function to ensure that you create a specific list. And you don't have to create a for loop and keep putting the value of x into a list to ensure that you've created one. List comprehension does it for you in one single line. Let me explain how. The basic syntax for list comprehension is an arbitrary list name, and then you put in brackets the expression for a variable in a range. Obviously, in range, like I mentioned for a for loop, is not necessarily all that we use. And keep in mind that this section here, for variable in range, is exactly how a for loop looks. That's because list comprehension takes the use of for loops, if conditions, while loops, to ensure that you have a list that is complete. In this example down here, cart is a list. Instead of saying for item in cart and you append the item to the list every time, all you have to do is just say the expression, in this case item, that you want to add to cashier, and then what you would do with item, specifically for item in cart. Now some more examples to help you understand exactly how list comprehension works. If you look at this example here, even numbers equals I for I in range 1 to 10 if I mod 2 equals 0. I, the first I, is the expression itself. This is what gets sent to your list. You can change I to I squared, or I cubed, or I divided by 2, and it will give you this different results. But I divided by 2, or I squared, is what goes into your list. Everything else, for I in range 1 to 10, if I mod 2 equals 0, is which i's go into your even numbers list. In this case, we're saying, for I in range 1 to 10, giving the values of 1 through 9, if the remainder of I when divided by 2 is equal to 0. What this does is that it gives us all the even numbers in the specified range. You can also use an if-else statement to determine the expression. Say for example you have this function, even or odd. It equals, like I mentioned before, the expression even if I mod 2 equals 0. Else odd else odd for I in range 10. What this does is it gives you two choices of the expression. Unlike here where we only have I, we can choose between even and odd depending on the if statement. And we also at the end specify the I, which is again in range 0 to 10. Finally, we'll be going over the functions and lambda section of this lecture. Perhaps the most important thing for you to take out of this Intro to Python course. Functions are a block of code specified under one name, like a variable, that runs when you call the name. The basic syntax of a function is to define a name, given parameters, and then put in said code. Sometimes you return a value, and sometimes you don't. When calling a function to use it, just use the name, and then put in your arguments. Now just a quick note, when I use the words parameters and arguments, an argument is the external value that you input to a function, while the parameter is the name of the variable in the actual function that you'll use to manipulate. Say for example, when I'm calling the function name, I input the variable y. But when I'm defining the function, I define it name parameter. In my actual function, I'll use the variable name parameter, and manipulate that in the code. But when I input an argument like y, the parameter equals y. This sounds complicated, but it will get more simple as you do more functions and look at the implementation section. Now another thing to note when it comes to functions is the return of a value. Now when you return values of functions, this is optional. Sometimes all you do in function is you do some code that changes the way a variable works. But once in a while, you can return values that actually go into variables. Therefore, when you call a function, it can sometimes equal a variable because you will return a specific value into the variable. Say for example, I have a function that always gives out the number plus 2. When I input the number 2, the function outputs 4, and I can save it in a variable like answer. Finally, lambda functions. Lambda functions, like list comprehension, are kind of like the same thing, where you can put a function condensed onto one line. Lambda functions need a variable or a name to be assigned to them because that name is now becoming effectively the function. The example here is lambda of x, and then the colon x plus 2. X is the expression, or rather the variable that you get, that you return. Well, x plus 2 is how you manipulate the variable. Now lambda functions usually take an input of, in this case, x. So if I had a lambda function assigned to a specific name and I inputted the variable 2, the lambda function would return 4, because it's 2 plus 2. Thank you so much for listening to the Intro to Python section of this course. Please check out the implementation section to get a further understanding and a grasp on the concepts actually being used in a coding sense. If you have any questions, please feel free to reach out to SMLC. And also check, like I mentioned, the best databases, like online, or the implementation section as well. Good luck in the future sections of this course, and thank you.